Okay, here are two statements, and I want to sort of examine these statements in terms of proving and disproving using both inductive and deductive reasoning. Okay, so this first statement, the product of two odd numbers will be an even number. And the second statement, almost the same, but we have the word sum instead of product. The second statement is the sum of two odd numbers will be an even number. Okay, so let's look at the first one. The product of two odd numbers will be an even number. Now, what we want to do here is either prove or disprove these statements. Now, it's a lot easier to disprove a statement because to disprove a statement, you only need one counterexample. So, for example, the product of two odd numbers. So let's pick two odd numbers at random. Let's say 3 times 5. Remember, product means multiply. The product of two odd numbers will be even. Well, 3 times 5 is 15, which is not an even number. Okay, so that's not even. So this statement is false. And that's it. That's all it takes. To prove a statement is false, you need one single counterexample. Okay, now let's look at the second statement. The sum of two odd numbers will be an even number. Well, what about 3? So remember, sum means plus. So let's say 3 plus 5. Well, that equals 8. I'm just picking numbers at random. Let's say 7 plus 11. Well, that equals 18. And let's say 5 plus 9. That equals 14. And let's do one more. Let's say 7 plus 19. Well, that equals 26. Okay, so we have an even number, even number, even number, even number. That's what we're looking for, even numbers. But we haven't actually proven anything. What we've done is we've compiled some data that sort of tells us this is probably a true statement. But we've only proven it for these 4 specific cases. So to say that because of these 4 cases, odd plus odd equals even, well, that's an example of inductive reasoning. Inductive reasoning, or proof by example. So inductive reasoning is not an adequate way to prove a statement. So we need to prove this is true for all odd numbers, infinitely many odd numbers, not just the 4 specific cases that I've chosen. So let's talk about how to prove this using deductive reasoning. Now remember, deductive, we start general and we come up with a specific conclusion. Okay, so let's separate this and let's talk about deductive reasoning. Deductive reasoning. Okay, so the sum of two odd numbers. Well, instead of picking specific odd numbers, what is an odd number? What does an odd number look like? Well, let's start with even. Actually, let's start with even numbers. An even number. So let's think about, like, in terms of the definition, an even number is a multiple of 2. Is a multiple of 2. So any number that's divisible by 2 or is a multiple of 2, this is the definition of an even number. So let's say an odd number. An odd number, well, is 1 more than an even number. If you take any even number and you add 1, you get an odd number. Is 1 more than an even number? All right, so let's start with just a generic variable x. Let's say x equals any number. So any, well, whole number. We're not talking about decimals or fractions, but x is any whole number. Okay? So how do we make an even number and how do we make an odd number? Well, an even number, so if x is any whole number, then 2x is even, and 2x plus 1 more than an even number, is odd. Okay, so this is what an odd number looks like. If x is any number, then 2x plus 1 will be an odd number. 2x is even. 2 times anything is even. So 2x is even and 2x plus 1 is odd. All right, so now let's go back to the problem. The sum of two odd numbers. What does that look like? The sum of two odd numbers. Let's come over here. And, well, we have two numbers. So instead of just using x, let's use x and y. X and y are any numbers. So we could say, well, the first odd number, 2x plus 1, that's an odd number. And we'll add another odd number to that, 2y plus 1. Okay, so we have our first odd number here, and we have our second odd number here. Okay, so 2x is obviously even because it's 2 times something. So 2x is even, 2x plus 1 is odd, and 2y plus 1 is another odd number. All right, so we have two odd numbers here. Okay, let's make this a little smaller so we can fit everything in the screen. All right, so 2x plus 1 plus 2y plus 1. Well, that's 2x plus 2y plus 1 plus 1. So we have a 2x, a 2y, and we have a pair of 1s. Or there's 1 plus 1 is 2, okay? So 2x plus 2y plus 2. And now each of these three terms has a 2 in it. So we could factor out that 2. So that equals 2 times x plus y plus 1. And since we have 2 times something, well, we know this has to be an even number. So what have we done? We've started, so let me use something fancy here. Okay, we've started with two odd numbers. Not two specific odd numbers, because we don't want to use inductive reasoning. We started with two generic odd numbers, we added them up, and we came up with 2 times something, which is an even number. And since we haven't chosen any specific numbers, what we've done here basically is proven for all numbers, for all odd numbers, that the sum of any two odd numbers will be even. So this checks out. And this is an example of deductive reasoning. So we start general. And so the starting general is right here. X is any number. So we're not starting here like specific numbers. We're saying x is any number. In general, any number. And we've come up with a specific conclusion that odd plus odd equals even. And that is an example of proof by deductive reasoning.